Good morning students. Welcome to the session where we are going to discuss about ZieglerNatta polymerization. This class is an introduction of ZieglerNatta polymerization, which is a type of addition polymerization. Earlier sessions we saw what is addition polymerization, condensation polymerization and copolymerization. In addition polymerization we saw three mechanisms which is free radical, anionic and cationic polymerization. We discussed all these three with examples. This class we are going to discuss about ZieglerNatta polymerization, which is an addition or chain growth polymerization. Now, ZieglerNatta polymerization. This type of polymerization was discussed by the scientists Ziegler and Natta. These are the two scientists. They discovered this polymerization in 1953 and 1955. So, what did they do? They took combination of transition metal halides such as TiCl4 or TiCl3, zirconium halides, or even halides of other transition metals such as vanadium, zirconium, chromium, molybdenum, tungsten. So, they took halides of these transition metals and they embedded it with organometallic compounds such as triethyl aluminium, trimethyl aluminium to form a complex. So, this complex is called as ZieglerNatta complex. I am writing it as Zn complex, ZieglerNatta complex. So, what is the advantage of this complex? It can form highly stereospecific polymers, either atactic polymers, syntactic or isotactic polymers can be formed by this. This is the advantage of ZieglerNatta polymers. Usually we use polyethylene, polypropylene, polydienes, etc. for ZieglerNatta polymerization process. So, what do we do here? What are the mechanisms that is involved in this polymerization? So, these are the three steps: initiation, propagation and termination. During initiation, you prepare the ZieglerNatta complex catalyst, and this catalyst, it reacts with the monomer to form a complex of this type. This is also a complex and this is highly reacting species. Reacting, initiating species like this is formed. So, this catalyst, it is involved in the reactions that are seen in the coordination polymerization, which generally includes the complexes and that are formed between a transition metal and n electrons of the monomer. Polymerization usually takes place by the insertion of this monomer. You have this monomer where the transition metal ions are attached to the end of the polymer chain. Okay. So, this takes place here. The incoming monomers are simultaneously coordinated. You take this monomer, they are simultaneously coordinated at the vacant orbital sites. Wherever there is vacant orbital sites, they have simultaneously coordinated here and at the vacant orbital sites, and there is formation of a long polymer chain like this. The C double bond C is also, here you have the C double bond C is also inserted into the TiC bond of the active center. The chain growth polymerization finally enters into the termination step where dead polymers are produced. So, this is your desired products, and the reactions also resemble anionic polymerization that lead to linear and stereoregular polymers. Here, to sum up again, you can see in the initiation step, the ZieglerNatta catalyst, it adds to the monomer, the n electrons of the monomer particularly reacts, and then initiating species is formed, and what happens? You have a propagating species that is formed over here, and this reacts with the active hydrogen compounds and forming the dead polymer, which may be linear, stereoregular or stereoregular polymers may be formed. If you see the applications, main applications are, they are used in the synthesis of high density polyethylene, low density polyethylene, and also polyolefins, polybutylene, crystalline polypropylene, nanotubes, particularly this you can see many applications, nanopolymers are applied all over the world in several applications, starting from textile field to electronics field. We are using it everywhere. So, carbon nanotube nanocomposites can be prepared. This is one of the important application of the polymer. And the limitation of this is you cannot synthesize PVC or acrylates using this process. So, this is about ZieglerNatta polymerization. Summing up the application again, ZieglerNatta polymerization is used in the preparation of compounds such as LDPE, HDPE, polyolefins, polybutylene, polypropylene, carbon nanotubes, nanocomposites, etc. And their limitations are they cannot be used in the synthesis of PVC and acrylates. So this is about ZieglerNatta polymerization. Unit 3. Thank you for listening.